that yet.
I tell you, Wednesday makes these weeks seem long to me.
I know it. No,
It's a good day,
Yeah.
so I gotta wake up and go to football, then come home and do my work.
It's a good day until I have to wake up.
I don't know how those kids do it, the online people.
Quite honestly,
I would
Not a lot
not
of
do
them do.
anything.
Oh,
I've
I
got,
would procrastinate.
yeah,
I've
same.
got a handful that do what they're supposed to, but it's the minority.
Only reason why I do that is during deer season.
You're just doing your work on your hotspot in the stand.
Uh-huh.
I could have that, to be honest. I know my dad would have done it.
Has anybody started on Miss Perry's book?
Yes. Just kidding, we don't have the same class.
Talking to the other 3 people.
How
Think
does
you do them all the time?
I think it's funny how Adam said social media ruins lives and got an Instagram account over quarantine.
Wait, yeah, he did, didn't he?
Okay, second period, 1, 2, 3, 4, 5, those here, save that, and put those grades in there.
Oh.
I played a video of him shooting the ski. What happened was split the car and boom, there's a location.
Oh, yeah. I think I'm missing. I agree, sir.
We're starting right now. Can you wait a little bit? Okay, on the, bell ringer, everybody did get it correct, so good job on that. So, today's stuff, I'm not gonna say the answer because it's on the camera already, but today's stuff, we're gonna be adding, subtracting, and multiplying. And we've already done some multiplying when we were doing quadratics, so you already knew what to do with that, so not that big a deal. Okay, I had a, request, they said they haven't been able to hear me as good lately, so I gotta try to remember to stand closer to the camera, in case you're wondering. Alright,
Don't forget to stand closer.
I know. I'll try to work
I
it out.
reminded you I didn't go.
I appreciate it. Alright, so I'm gonna give us 2 polynomials here to start with to add. This is a pretty simple lesson today. What we're working our way up to, go ahead, Kristen, I'm listening to you.
Do we need our Chromebook?
No, you're good and done with your Chromebook. What we're working our way up to is being able to solve these polynomials. And we learned how to solve quadratics last unit, but now we're working our way up to having a higher power than 2. So a cubic, a quartic, or a whatever. But this, just learning to work with them today is pretty simple. Alright, so we've got 2x cubed minus 5x squared plus 3x minus 9. That's one polynomial. Then on the other side of the board, I got x cubed plus 6x squared plus 11. So I've got 2 cubic polynomial functions there, right? So what we're going to do with them is add them. So I'm going to show you 2 different methods you can use, and it doesn't matter to me, whichever you like better. So the first way I'm going to do it's just called horizontal. So I'm just going to leave them in a long horizontal line like they are, and I'm adding them, so I'm going to throw a giant plus sign in there. And so now all I'm going to do is look for like terms to combine. So I would say, okay, here I got 2x cubed, and I'm adding that to a 1x cubed, so I know I'm going to have a 3x cubed. Okay, see, pretty simple stuff. Now I've got a negative 5x squared, and I'm adding that to a positive 6x squared. I can only add like terms. That means the power's going to be exactly the same. So negative 5 plus 6 gives me a 1x squared. I can put the 1 or not. Okay, now here I got a 3x, and I come over here, and there's not a 3x, so it's just like 3x plus 0x, so that would stay 3x. And then my last one, I have my constant. I got a negative 9 plus a positive 11. So I'll get plus 2. And that's it. You can't combine anymore. It's in standard form because I'm 3, 2, 1 constant. So that's all you can do. Now, another method for doing the same thing, that was called horizontal. So vertical would be the other method. So I'm going to write my first one. Now when I do this, oh, that's a cubed. When I do this vertically, I got to pay attention to missing terms. That one doesn't have any missing terms, 3, 2, 1 constant, so it's good. But when I go to put this other one underneath it, I want to line up the like terms, so I'm gonna put the x cubed under the x cubed, the x squared under the x squared, but I don't have an x to the first in this one, right? So I either am gonna put a 0 there or just leave a big blank. And so now you've got them stacked up vertically like you did when you were a little tot, and you just add them that way. So 2x cubed and 1x cubed, negative 5x squared and 6x squared, 3x and nothing, negative 9 and 11. So you get the same answer either way. In my opinion, what I would tell you to do is however it's set up, because I think it's too easy to waste time on. If they give it to you and it's all in horizontal like that, just start looking for your like terms. Don't, unless you're just totally engrossed in this vertical and they give it to you like this, don't waste time rewriting it here. I don't think it's that hard that you have to. But if they give it to you this way, do it that way. Don't take time rewriting it. You know what I mean? It's easy either way, right?
Yeah, both of these are pretty easy.
Yep. All right, so same concept when we go to subtracting. So let me get a subtraction problem for us. I've got 3x cubed plus 2x squared minus x plus 7. And then we're going to subtract 8x cubed minus x squared minus 5x plus 1. Okay, and I'm going to do this one both ways as well, just so you get some experience seeing it both horizontally and vertically. What you have to be careful with here, when I do it horizontally and I put the big subtraction sign here in the middle, I got to remember that that means I'm subtracting every one of these terms. So it helps my pea brain if I put that second one in parentheses. You don't have to, but it helps me. Okay, so my highest power over here is a cubed, and I've got a cubed over here, so 3x cubed minus 8x cubed. That'll get me negative 5x cubed. Okay, let's go to my squareds now. 2x squared, and check out your signs here, 2x squared minus negative 1x squared. So that's 2 minus negative 1. What do you get on that? Plus what?
3x.
3x squared. Very good, sir. Now be careful again on your x to the first, because you got a negative 1x minus a negative 5x. So what's negative 1 minus negative 5?
Negative 6.
Nope.
No.
Oh, wait, no.
Negative 1 minus,
Would it be 4x?
uh-huh. Because that would change that to a plus plus, so good job. That'll be a positive 4x. And then on your constant, that's pretty straightforward. 7 minus 1, so positive 6. And that'd be your answer. Can't combine any more. I wonder, I bet I'm muffled too because talking through this. How's your day going? You look a little sleepy. Did you not get a good night's rest? I'm sorry. That just makes my day sad.
Sorry.
I know. Well, I am. All right, let me do it horizontally now. Oh, that was horizontal. Let me do it vertically now. So 3x cubed plus 2x squared minus x plus 7. I'm going to subtract this one. Luckily, this one's got the same 4 terms. I don't have to skip a space or put a 0 or anything, or a space. I just made up a word. 8x cubed minus x squared minus 5x plus 1. Now again, this is subtraction, so I'm going to have to go hit that subtraction sign every time. Can't forget. 3x cubed minus 8x cubed. 3 minus 8, just subtracting your coefficients. 2x squared minus negative 1x squared, so 2 minus negative 1 is a positive 3. Negative 1x minus negative 5x, so negative 1 minus negative 5 is a positive 4, and then 7, don't forget my x, 7 minus 1. So same answer either way. easy schmeezy, everybody's got an A, right?
And couldn't you just plug all this into a calculator as well?
No.
Yeah.
No. How, what you talking about, Willis? You can't put variables in your calculator,
Oh, wait.
cause it makes up a random value for it and will try to work it all the way out.
Oh.
Unless you knew what X was.
Right, right.
Because then, if you knew what X was, you could store it.
Yes, yes.
Then you could.
But in every problem X will be something potentially different,
Yeah.
so. Okay, so let's do some multiply now, that's the fun stuff. That's what we looked at on the bell ringer, y'all were already an expert at. So, we're gonna have negative 2y squared plus 3y minus 6. And we're gonna multiply that by y minus 2. Okay, so I'm gonna do this one a couple of different ways also. We'll stick with the same two titles that I said last time, horizontally and vertically. So if I'm gonna do horizontally, it's just my personal preference. Horizontally, you're keeping them on a line, you're gonna distribute one to the other when it's multiplication. Would that make sense? I like to have the smaller one in front to distribute. Because remember, multiplication doesn't matter what order it's in. It's commutative. 4 times 2 is the same as 2 times 4. So I'm going to put this y minus 2 on the front side. And then I've got my negative 2y squared plus 3y minus 6. So doing it horizontally now, I'm just going to take this y, distribute it to all three of those. Then take the negative 2, distribute it to all three of those. And then combine any like terms that I have. Okay, so here we go. Y times negative 2y squared is what?
Negative 2y. Squared.
Cubed. Remember, and Christian said it a second ago, when you multiply, go back to your property rules, when you multiply, the exponents get added. Remember that? So this is an understood y to the first, so 1 plus 2 would make the 3. Good job. Okay, now I'm going to go y times 3y. What does that get us? Y,
It would just be 3y
3y
squared.
squared. Y times y makes y squared. Okay, and then my last y goes to that negative 6. Okay, good job so far. You're halfway done. Now we got to take the negative 2 and distribute it to everything. So I'll bring it on the bottom here, negative 2 times negative 2y squared. Negative 4y squared. And this is not negative. You didn't say negative, I did, but I'm wrong, right? Because a negative times negative is a positive. So that's 4y squared. And this is what I like to do. I like to go ahead and match my like terms up as I'm going. You don't have to do that, but it makes it simpler for me as I'm going. Okay, then I got my negative 2 times the 3y. What does that get us?
Negative 6.
Negative 6y. And then I got my negative 2 times the negative 6. So positive 12.
Teachers and students, last call for flu shot forms. Please turn them into the high school office at this time.
So now I've already got my like terms lined up that way, if you do it that way. If not, you'll just go and look and see if you can find them. But that dropped down my negative 2y cubed. 7y squared when I combine those, right? Remember, when you add and subtract, the powers stay the same. What's negative 6y and negative 6y?
Negative 12y.
Yes, no.
No,
Just
negative
negative 12y, right? Powers stay the same. And then I got my positive 12 on the end.
All
Okay.
these rules.
I know it. You gotta keep them straight. Okay, so we did that horizontally. Now I'm gonna do that same problem vertically. Multiplying vertically is kind of cool and kind of strange all at the same time. So,
Sounds different. And I don't know if I want it.
oh, you'll be all right. Let me erase this right quick. When you first started learning multiplication with triple, double, and triple digits in elementary school, you'd put the bigger one on top, put the smaller one on bottom. So then, same thing you did when you were in elementary school, when you were a little tot. We're gonna multiply this negative 2 times all of those, and that'll give us a line. Then we'll go down and multiply the y times all those, and then we'll combine those two lines. So it's the exact same thing.
But it also loses it.
Yes, you have to have that space holder, you're right. Okay, So negative 2 times negative 6 is a positive 12. And I put that positive in front of it because we're fixing to have a line of stuff here, right? Negative 2 times 3y is negative 6y. And then negative 2 times negative 2y squared is a positive 4y squared. Now, Christian remembered when he was in elementary school, he had to now, when he went to the next line, scoot over one. Some of your teachers might have put a 0 placeholder there. Everybody look familiar? Okay, y times negative 6, y times 3y, and then y times negative 2y squared. Now compare that to the way we did it the first time. It's the same, isn't it? I just had the 0 there is the only thing different. Combine your like terms, negative 2y cubed plus 7y squared minus 12y plus 12. So the question I reckon would be, do you like to distribute with your lines like that? Or do you like to distribute the first way with your lines like that? So that's up to you. It's,
The first way, yeah.
I'd probably just do it whichever way the problem was already written. Easy stuff, easy stuff. So that would have been use some math words here. That would have been a trinomial times a binomial, right? Okay.
Are we doing it on our own?
Oh, let's get all
We
the,
can't do one on our own yet.
let's get all, why is that not going to the next page over here? Let's get all the different types covered first and then we will. So now I'm gonna do 3 binomials. I got x minus 5 times x plus 1 times x plus 3. Okay? So different type here because we've got 3 binomials that we're multiplying. So just talk to me about what our plan of attack should be on this.
Distribute the first of both of them and then multiply those together.
Pretty close. I'm just gonna multiply left to right. So I'm gonna multiply my first 2 binomials and get an answer. And then like Christian said, multiply that answer times the last one. Make sense? Okay? So the binomial times the binomial. You can say FOIL, first, outer, inner, last, or you can just distribute. I got an x times an x. And then I got an x times a 1. And I got a negative 5 times an x. And then I got a negative 5 times a 1. Now, I could, because I'm done with the actual multiplication of those 2, right? So I could go ahead and bring this one down and start multiplying. I think it'll make your life easier if you combine your like terms first. Try to keep it simple as you go. So let's go ahead and combine those like terms. What do I get with x minus 5x?
Negative 4x.
Negative 4x. Okay, so now we got a trinomial. We got to bring this dude down to the party. Multiplied it by a binomial. Now I told you a minute ago that I like the shorter one to go first, but I'm just going to leave it. I can handle it, and you can too. I could take this x squared, and I'm not going to, but these are my options. I could take this x squared, distribute it to both of these, take the negative 4x, distribute it to both those, take the negative 5, distribute it to both those, and combine like terms. I could, but can I also work from the other side? Mm-hmm. So let's do that. Let's do x times x squared. Gets me an x cubed. X times negative 4x gets me what?
Negative 4x squared.
Yes, sirree. And then x times negative 5.
Negative 5x.
Yes, sirree. Okay, so all we got left now is the 3, and I'm going to try to match up like terms as I multiply it. So 3 times x squared. It's just 3x squared. Yes, sir. 3 times negative 4x. What do you?
Negative 12x.
Uh-huh. And then 3 times negative 5.
Negative
Alright, so we got two pieces of like terms to combine there. Drop down my x cubed. What do I get here? Negative 4x squared and 3x squared.
Negative x squared.
Yes, yes, yes. Negative 5x and negative 12x.
Negative 17.
And then drop down my negative 15. And that's it. Winner, winner, chicken dinner. Alright, let's do one more, then I'll give you a couple to try on your own. Three t plus 4 times 3t minus 4.
That T is gonna throw me off.
Put a different letter. I'm sorry. You can always put a different letter.
I'm gonna write a dozen.
Alright, so you walk me through it.
Okay, so multiply the first two,
Okay, what do I get on that?
6
Close. What's 3 times 3?
9.
It's because you didn't get that good night's sleep and threw your multiplying off. Okay, we're good, we're good. What about now?
The 3x multiplied by the negative 4x.
Okay, and that gets what Holly said. Okay, now what? Alright, the 4 to what?
3.
Okay, so that'll get me a positive that time. Oh, wow, I like that. Am I done?
No.
Okay, what do I do?
4 times negative 4.
Oh, okay, that gets me negative 16. Okay, what happens on this middle term here?
They cancel out.
Negative 12t or negative 12x and 12x, that's nothing. He gone.
Shield.
Now, do you remember when we did factoring of quadratics last unit, what that was called? We started with this, close. We started with this and we worked backwards and got here. Had to do with that minus sign and the perfect squares Tyler's talking about.
Completing the square?
No, what's a math word for minus that starts with a D?
different.
Difference of squares.
Difference.
It's a subtraction and they were both perfect
I
squares.
had the square part right.
Yeah, y'all were thinking good. Alright, so let me give you a couple of random ones to try. I'm not gonna concern you with the add and subtract. I think that's baby stuff. Y'all good with that? Alright.
It's already the 8th of October.
Number 1 will just be a monomial times a binomial. Number 2, we'll do a binomial times a binomial. Let me get a trinomial in on the fun. Number 3, we'll do a binomial times a trinomial. Okay, see if you can get those 3 multiplied there in your notes real quick.
What is the binomial version of one? Nomial?
A monomial. how you did. Let's see how you did. What was 5x squared times 6x?
30x cubed.
30x to the third, because 2 plus 1. What is 5x squared times 2?
10x squared.
Okay, and I haven't talked about this, but you know what sign goes between those? No? Good, it's just an add sign. If I had got a negative when I multiplied, I'd put a minus. If I get a positive, I put a plus, okay? Everybody feel good about number 1? Alrighty. So 3x times x on number 2, what'd you get?
3x squared.
Okay, and then I gotta go 3x times negative 3, what does that get me?
Negative 9x.
Okay, see, y'all knew about that sign. Okay, so I'm done with that 3x. Let's get the 1 involved now. 1 times x,
X.
positive x. And then on 1 times negative 3.
Negative.
And 90% of the time when you do a binomial times a binomial, you've got like terms to combine. So what do I get when I combine those?
Negative 8x.
3x squared.
Yes, you do. Good job.
Good job, Christian.
How'd you do on that one? Got it? Got it? Got it?
1.
Alrighty. Let me get me a little more working room down here for the big one. So let's take the 2x to all 3 of those. That sound good? What's 2x times x squared?
2x cubed.
And then I got a 2x times negative 10x.
Negative 28.
What?
Squared.
Good, Christian. X times an x makes that x squared. And then I got a 2x times a negative 2.
Negative 4.
Good job. Okay, we good with the 2x? Now we're going to distribute a negative 3 because it's got a minus in front of it. So negative 3 times x squared. Good. Negative 3 times negative 10x.
Negative 30x.
What?
30.
Positive 30x. Negative times a negative is a positive. Good. Negative 3 times negative 2.
6.
Positive 6. Combine those like terms that I lined up nice and pretty for you. 2x cubed. What do I get with the x squareds?
Negative 17.
Nope.
Negative 23x.
Negative 23x squared. What do I get with the x to the firsts?
26x.
Positive 26x. And then there's my constant of 6. Okay? All right. So all of that, you know, we just did a 1 add and 1 subtract. I showed you 2 different ways to do it, but that's stuff that you've been doing for a long time. This multiplying you've been doing for a long time too. So it's just takes a little bit longer to do those. But what tomorrow, I told you we're getting ready to start solving these. So tomorrow it's going to go backwards. We'll have this, and we'll work backwards and factor it to that, which we already did factoring with quadratics, but now our powers just might be higher than a squared. So there's a little bit more involved in the factoring. Okay? So by next week we'll be, maybe even a little bit tomorrow, but by next week for sure we'll be solving these things. Then when they got a higher power than 2.
It
Look it
feels
up.
like it was a repeat of something.
Well,
Feels like I've done this before.
yeah, you have. You've multiplied it.